Alright, here's the midpoint formula. You still have to be given these 2 points, x1, y1 and x2, y2. Then the coordinates of the midpoint are given by this formula right here. You average the x coordinates, so you add them together, divide by 2. Same thing with the y coordinates. Add them together, divide by 2. Your midpoint should return an ordered pair. You need an x coordinate and a y coordinate. Add them together, divide by 2. Add those together, divide by 2. Let me show you a quick graphic over here. Here's a little Cartesian coordinate system. Let's say this is, x1, y1. And let's put x2, y2 here. Right, those two ordered pairs. What the midpoint gives you, if you can imagine a line segment joining these two, it's the point that's exactly halfway in between here. That's your midpoint. Right, it should be the coordinates of the point that's halfway in between. So here's x1 over here, here's x2. The midpoint is exactly halfway in between those two. Here's y1's up here, y2's down there. Your y coordinate of the midpoint is halfway between those. Right, that's why you average them. We haven't done an example of the distance formula, so let's do that here. Let's find the distance between those two given points. If you remember your distance formula, you subtract the x coordinate square, add in the middle, and you subtract those y coordinates, square that. Alright, take a big square root. Alright, let's fill these in. x1 is 8. If I'm subtracting a negative 1, that's like adding. 8 minus a negative 1 is 8 plus 1. Alright, with the y's, that's negative 3 minus 4, and that quantity squared. Okay, 8 plus 1 is 9. If I square it, I get an 81. Plus a negative 7 squared is 49. If I add those together, 130. Okay. So leave your answer like that. I don't think my math lab, they don't want a decimal approximation. I think they want an exact answer like this. But if this were to simplify, make sure you simplify it. That 130, I don't think has a factor of it that is a perfect square. Okay. Let's scroll down a bit, see what's down here. Oh, yeah, let's go to the book. You can either pull up the ebook or just get your book in front of you. Number 32 on page 155. You really don't even need your book. I'm going to tell you what it says. They give you these 3 points, A, B, and C. And it says plot each point, form the triangle ABC, and verify that the triangle is a right triangle and find its area. Right, so we're going to do all of that here. Let me draw these. Alright, let's plot A. Negative 6, 3. 1, 2, 3, 4, 5, 6. Negative 6, positive 3. It's about right there. Here's A. B is positive 3, negative 5. There's B. Alright, and C is oh man, I lost that B again. 1, 2, 3, negative 5 is right here. Alright, C is negative 1, positive 5 is here. Alright, there's C. So, yeah, it looks like C is always your right angle. That's how it looks like. We have this drawing. It doesn't have to be perfect. It's just a sketch. That does look like a right angle right there. But that's what we want to verify. So we will use the Pythagorean theorem to verify. But we need to find these distances first. I need to find the lengths of all those sides. So let's find that longest side. Let's do AB. It's actually the hypotenuse. Let's do the distance from A to B. See how that comes out. I need a big square root from A to B, these first two right here. That'll be a negative 6 minus 3, that quantity squared, plus 3 minus a negative 5, so I'm adding 5. I need to square that. Right, let's see what we get. This is a negative 9. If I square it, is 81. And 8 squared is 64. So that is 145. Alright, 145. Alright, I don't think that has a factor of it. That is perfect square. Let it go. Okay, that's a square root of 145. Let's leave it like that. Now, that's distance from A to B. Let's try from B to C. Yeah, let's look at the distance of that line segment. Alright, from B to C, let's subtract those x's. 3 minus a negative 1, 3 plus 1 squared. And the difference in the y's, negative 5 minus 5, that quantity squared. Alright, 3 plus 1 is 4, squared is 16, and that's 100. Negative 10 squared. Right, so I get a square root 116. 116 divides out by 4, so this is actually 4 times the square root of 29. Square root of 4 times the square root of 29 gives me 2 square root 29. Alright, all we're doing so far is finding the length of these line segments. I found from A to B, square root 145. I found from B to C, which was 2 square root 29. Or we can leave it as square root of 116 because that's not our final answer. Now, we just need from A to C. Alright, let's find that one out. From A to C. From here all the way down there, negative 6 minus a negative 1. Gotta square that. Plus 3 minus 5. And then square that. Alright. That's a negative 5. If I square it, will give me 25. This is a negative 2. If I square it, I get a 4. That's a plus. Jeez. Alright, that's plus. So, square root 29. Alright, that's this side over here. Alright, so I have the lengths of all of these sides. So what I want to do now is try to verify the Pythagorean theorem. Let me try and do it up here, because I don't want to scroll down and miss all this. So let's take this side right here, the square root of 29. Again, you have to square that, plus this other leg over here. Instead of writing 2 square root 29, let's write the square root of 116. So I'm going to end up squaring that. We want to see, is that equal to the square root of 145 quantity squared? Right, that's the question. That's what we're trying to verify. Let's go ahead and square that square root. You get 29. If I square this square root, I'll get 116. If I square that square root, get 145. Alright, adding those together. 145 equals 145. Check. Yes, this is a right triangle. We did our distances. Correct. That's good. So, Now, your area of a triangle, 1/2 base times the height. My base and my height are those two perpendicular sides. So, looks like this. 1/2 times the square root of 29 times 2 square root 29. This 1/2 will cancel with that. Square root of 29 times square root of 29 is 29. So they're square units. I think you have ones like that to do in your homework, so there's kind of a lot of work to do, though I'd say it's more tedious than difficult. It's not difficult, it's just like a lot of writing that you have to do. You have to do the distance formula 3 times, verify the Pythagorean theorem, and then find an area. Alright, yeah, that one was about 10 minutes, almost 11, so we've got one more video for this section.